Alright, let's start with a basic idea. Imagine you are sitting at your computer waiting for something to load. Break it down and define exactly what it is. At its core, a thread is just a sequence of instructions that your computer follows to complete a task. Concurrency occurs when multiple threads are running at the same time and they try to access shared resources. This is when things can get tricky. Imagine a kitchen where multiple chefs are working. We have the term mutex. So mutex stands for mutual exclusion. A mutex is used to ensure that only one thread has access to a particular resource at a time. Hey everyone, welcome to Preptrain YouTube channel. I am Sahib Kumar and I'm thrilled to have you here today as we will be diving into another exciting engineering topic that will help you level up your skills. Here on Preptrain, we are all about learning, growing, and giving you practical tips to become a more confident and capable engineer. Whether you are a college student, a recent grad, or just passionate about backend development, you are in the right place. We will break down the complex topics into simple, actionable steps, making sure that you walk away with skills that you can apply immediately. Now, today's topic is something every developer eventually encounters. Have you ever found yourself staring at your computer and wondering that why your code is running so slowly? Or even worse, why is it not working at all? Well, you are not alone. The answer often lies in how tasks are being handled behind the scenes. And that's where multithreading comes in. Understanding multithreading can make your software faster, more efficient, and a whole lot of smoother. And trust me, once you get the hang of it, you will wonder how you ever developed without it. If you want to keep growing as a developer, be sure to hit that subscribe button and turn on notifications so that you never miss out on any new videos. We will post a lot of content designed to help you sharpen your skills and stay ahead of the curve. Now, today's video is packed with valuable insights and practical steps that you can start using right away to improve your code performance. We will cover the basics, but also dive into some challenges you will face and how to overcome them. Alright, let me just grab my deck and then we will continue diving deeper into multithreading and why it is such a game changer. Alright, let's start with a basic idea. Imagine you are sitting at your computer waiting for something to load and you see that little spinning icon, it could be faster, right? Well, here is the thing. Your computer is capable of doing more than one task at a time, and this is where multithreading comes into play. Multithreading allows your computer to break down tasks into smaller pieces and work on them simultaneously. Think of it as having multiple chefs in the kitchen, each working on different parts of a meal. Instead of one chef doing everything one step at a time, multiple chefs can work together, chopping, grilling, and plating all at once. This makes the process faster and more efficient. And now, while multithreading sounds like a silver buffet, it's not without its challenges. While multiple tasks are running at the same time, they might not always play nice with each other. And this is where concurrency issues come into the picture. For example, if two chefs try to use the same pan at once, chaos can ensue, right? So in programming, this can result in issues like race condition or deadlocks, which are the main challenges. And we will discuss in this in presentation. Race conditions occur when two or more threads try to access and modify the same resource simultaneously, leading to unpredictable results. Deadlock happen when two threads get stuck waiting for each other to release a resource and causing both tasks to fail or halt. These are the problems of concurrency that we will dive deeper as we'll be moving forward. And as we go through today's deck, I will be explaining how multithreading works, the benefit it brings, and how to manage the challenges that comes with it. By the end, you will be having a solid understanding of how to use multithreading to make your programs faster and more efficient while avoiding the common pitfalls. Now that we have introduced the concept of multithreading and some of the issues it can bring, let's move forward and define what multithreading actually is and how it works. Now we have a general understanding of why multithreading is important. So let's break it down and define exactly what it is. At its core, a thread is just a sequence of instructions that your computer follows to complete a task. Think of it as a to-do list that the computer executes step by step. But here is the thing, a computer does not have to follow just one to-do list at a time. This is when multithreading comes in. Multithreading allows multiple threads to run at the same time, meaning that your computer can execute several tasks simultaneously. So imagine it like adding more chefs to the kitchen instead of one chef doing all the work. So now you have a team and each chef can work on a different part of the meal, and one chef could be chopping vegetables while another one is grilling meat, and another one is preparing dessert. And this way, the entire meal gets done faster. Now, this is particularly useful for tasks that can be split into smaller independent jobs. For instance, when you are loading a web page, so one thread could be responsible for loading images, another for loading text, and yet another for handling scripts. So by running this task in parallel, the web page loads much faster than it had to wait for each piece to load one after the other. So the key takeaway here is that the multi-threading improves performance by allowing multiple tasks to be handled at the same time. This is especially effective when tasks can be broken down into smaller parallel jobs that don't depend on each other. However, as we will see later, managing multiple threads can also introduce some challenges, especially when those threads need to share resources. Now that you know that what multithreading is and how it boosts performance, let's talk about issues that arise when multiple threads try to access the shared resource. This brings us to the concept of concurrency. Alright, so concurrency occurs when multiple threads are running at the same time and they try to access shared resources. This is when things can get tricky. Imagine a kitchen where multiple chefs are working at the same time. So everything is going smoothly until two chefs reach for the same pan at the same time. So without coordination, again, chaos will occur. In programming, this uncoordinated access to shared resources can lead to problems like race conditions and deadlocks. So let's dive deeper into these two main concurrency issues. And first, we will discuss race condition. So a race condition can happen when two or more threads are competing to modify the same piece of data, and the results depend on the order in which the threads execute. So this is problematic because the outcomes become unpredictable. So it's like two chefs fighting over the last ingredient in the kitchen. Depending upon who gets it first, the dish might turn out completely different. So in programming, this can lead to inconsistent or incorrect results. For example, imagine two threads both trying to update a shared bank balance at the same time. So one thread is trying to withdraw money while another one is trying to deposit the money. And if both threads modify the balances knowing what the other is doing, final balances could be wrong. Next, we have a deadlock. So a deadlock occurs when two or more threads are stuck waiting for each other to release a resource. Neither can move forward, and it's like two chefs kneading the oven, but each one is waiting for other to finish using it. So neither of them can proceed. So the whole kitchen comes to a standstill. So in programming, deadlocks can freeze your application, causing it to stop responding because threads are locked in a cycle waiting for each other. So both of these issues, race condition and deadlocks, are common in concurrent programming, and they can be a major headache if not handled properly. So the good news is that there are ways to manage both of these problems, which we will cover in next few slides. Now that we have looked at the problem concurrency and introduced like race condition and deadlock, let's move on to the next slide where we'll discuss some key terminologies that will help you understand how to resolve actually these issues. Okay, first we have the term mutex. So mutex stands for mutual exclusion. A mutex is used to ensure that only one thread has access to a particular resource at a time. Think of it like giving each chef in the kitchen a key to the oven. So only one chef can have the key at a given time. So no two chefs can use the oven simultaneously. In programming, mutex prevents multiple threads from modifying the same resource at once, ensuring that there are no race conditions. Next, we have locks. Locks are similar to mutexes in the way that they prevent multiple threads from accessing the same resources at same time. However, locks can be a bit more flexible. Think of a lock as a door to the fridge in our kitchen, right? So only one safe can open the fridge at a time. But once the safe is done, the lock is released and another safe can access it. Similarly, in programming, locks ensure that while one thread is working with a resource, other threads are blocked from accessing it until the lock is released. Finally, we have the concept of a thread pool. So a thread pool is basically a collection of pre-created threads that are ready to be assigned tasks. So instead of creating and destroying threads every time a new task comes in, So a thread pool keeps a set of threads on standby, ready to jump into action whenever needed. So this is more efficient, especially for tasks that are short and frequent. It's like having a team of chefs always on call, ready to prepare a dish as soon as the order comes in. So rather than, a new order has come in, so I will hire a new chef every time. So we will be having a team of chefs always ready. These three concepts, mutexes, locks, and thread pools, are essential for managing concurrency and ensuring that your program runs smoothly without conflict between the threads. So they help you avoid the issues we discussed earlier, like race conditions and deadlock, by controlling how and when threads can access shared resources. Now that we have covered these key terms, let's move on to the fun part, the real world of application, where I can show you how multi-threading is used in some of the technologies we interact with every day. Alright, so first let's talk about web servers. Imagine a popular website like Amazon or Google, which receives thousands, if not millions of requests every second. Every time someone loads a page, a request is sent to the web server. Now, if the server had to handle so much request, each request one at a time, it would take forever for the website to load. So instead, web server uses multi-threading to handle multiple user requests simultaneously. One thread might handle loading the images, another might load the text, and yet another might handle the scripts running in the background. So this parallel processing ensures that the website loads quickly and efficiently, even under heavy traffic. Next up are video games. So video games are a prime example of how multi-threading can make a complex system and make it run smoothly. So in modern video games, different threads are responsible for different tasks. So one thread might handle the graphics rendering, another one could be managing the entire physics engine like collision or character movement, and a third thread might be dedicated to handling user input from a keyboard or a controller. So by breaking this task into multiple threads, the game can run smoothly without any noticeable lag. Finally, let's talk about social media apps. Platforms like Instagram, Facebook, and TikTok rely heavily on multi-threading to deliver content without delay. For example, when you open Instagram, multiple threads are working in parallel to load images, videos, and text as you will scrolling down. One thread might load the content at the top of your feed, while another thread is preloading videos further down the pages. This makes your experience seamless and it allows you to scroll without having to wait for each piece of content to load one at a time. So as you can see, multi-threading is all around us, whether it's making sure that your favorite website loads fast, or ensuring that your video game does not lag, or helping you scroll through social media without interruption. Multi-threading plays a crucial role in making sure that these applications run smoothly and efficiently. Now that you have seen how multi-threading is used in the real world, let's move on to some of the challenges that comes with it, especially the concurrency challenge like race condition and deadlock, and how we can overcome them. First, let's revisit race conditions, and as we mentioned earlier as well, that a race condition occurs when multiple threads try to access and modify the same shared resource at the same time, leading to unpredictable results. So the problem here is that the outcome depends on the order in which the threads can execute, which is sometimes we cannot even control. So to avoid this, we use more mutexes and locks to ensure that only one thread can modify the resource at a time. And by locking the resource, we can prevent multiple threads from accessing it simultaneously. So ensuring that the data remains consistent and accurate. Next, we have deadlocks. So a deadlock happens when two or more threads are waiting for each other to release a resource. And as a result, none of the threads can proceed. So again, like I said earlier, so it's like two chefs in the kitchen waiting for each other to finish using the oven, but neither can move forward because they both are stuck waiting. So deadlock can completely freeze your program, and they can be tricky to debug because it's often hard to trace which threads are waiting on which resources. And to avoid deadlocks, it's important to follow proper locking protocols, such as always acquiring locks in the same order to prevent circular waiting. Finally, let's talk about solution. As I mentioned earlier, that using mutexes and locks is one of the most efficient way to avoid race condition and deadlock. Another solution is to synchronize your threads and making sure that they don't access the shared resources at the same time. By carefully managing how and when thread interact with the shared resources, you can prevent the type of conflicts that lead to concurrency issues. In short, a concurrency challenges like race conditions and deadlock can be a real headache, but with the right tool like mutexes, locks, and synchronization techniques, you can manage these challenges and ensure that your multi-threading programs run smoothly. Now that we have covered the challenges and some solutions, let's talk about mutexes and locks in more detail and how they help ensure thread safety in your program. First up is the mutex. So a mutex ensures that only one thread can access a resource at a time. Think of it like giving each chef in the kitchen a key to the oven. If chef A is using the oven, chef B cannot just walk over and start using it too, because chef A physically has the key. So in the context of programming, mutexes work in exactly the same way. If multiple threads need to access a shared resource like one piece of data or a file, so mutex makes sure that only one thread can access it at any given moment. Once that thread is done, it releases the mutex, allowing the next thread to take over. Let's take a practical example. Imagine you are writing a program where two threads need to upload the same bank balance. Without mutex, both threads could try to modify the balance at the same time, which could lead to inconsistent results. One thread might withdraw money while another deposits money, and depending upon the execution order, you could end up with an incorrect balance. So by using a mutex, you can ensure that only one thread updates the balance at a time, preventing any conflicts. Next, we have the locks. So lock functions similarly to the mutexes, that they prevent multiple threads from accessing a resource at the same time, but they offer additional flexibility. Locks are incredibly useful for preventing race conditions by ensuring that threads don't step on each other's toes when accessible shared data. Now, what about thread safety? So, thread safety refers to a situation where your code can be safely executed by multiple threads concurrently without causing any race conditions, deadlock, or inconsistent results. By using mutex and locks, you can ensure that your code is thread safe and it controls how threads interact with shared resources. This is crucial in any multi-threaded program, as failing to make your code thread safe can lead to unpredictable behavior and bugs that are difficult to trace. In summary, both mutexes and locks are essential tools for managing concurrency and ensuring that multi-threaded programs run smoothly. They help prevent race conditions, deadlocks, and other concurrency issues by controlling access to shared resources. Now that we have discussed mutexes and locks, let's move on to thread pools and explore how they help manage multiple tasks more efficiently, especially in applications that handle a high volume of short-lived tasks. So, a thread pool is like, as it sounds like, a pool of pre-created threads, as you can see here. Instead of creating a new thread every time a task needs to be executed, a thread pool allows you to reuse threads for different tasks. So this is especially useful for applications that need to handle a large number of short tasks like web servers, database queries, or background processes. So let's break them down, how a thread pool works. Imagine you are running a busy restaurant, and instead of hiring a new chef for every order, you have a team of chefs standing by, right? So when an order comes in, one of the chefs can take the task, prepare the dish, and then return to the pool and ready for the next order. This is exactly how thread pool operates. When a task comes in, a thread from the pool is assigned the task. Once the task is completed, the thread is returned back to the pool, and it can be then again assigned to the next task. So why are thread pools so important? The main advantage is efficiency. Creating and destroying threads is an expensive operation in terms of system resources. If you are constantly creating and destroying threads for every task, you will introduce a lot of overhead. So a thread pool solves this problem by keeping a set of problems of threads alive and ready to be used. So this reduces the overhead of constantly creating and destroying threads, making your application much more efficient, especially when handling short, frequent tasks. So thread pools are commonly used in web servers. For example, when you visit a website, the server does not create a new thread from scratch. to handle your request, and instead it pulls a thread from the pool, process your request, and then returns the thread to the pool for future uses. So this allows the server to handle thousands of requests simultaneously without introducing delays or performance issues. Another advantage is that thread pools help prevent resource exhaustion. Since the number of threads in the pool is fixed, you can control the maximum number of concurrent tasks your application can handle. So this prevents your system from being overwhelmed by too many threads, which could lead to, again, slowdowns or crashes. So in other words, thread pools can help you manage resources more effectively. Basically, in summary, thread pools are a powerful tool for managing multiple tasks efficiently, and by reusing threads instead of creating new ones for every task, you can actually reduce overhead and improve performance and prevent resource exhaustion. This is especially useful in applications like web server or services that handle a high volume of short tasks. We have covered thread pools and how they improve efficiency. Let's summarize the entire takeaway that we have from this video. So first, we discussed what multithreading is, how it allows your computer to perform multiple tasks simultaneously by breaking down tasks into smaller pieces and running them in parallel. So multithreading improves the performance of your program, making them faster and more efficient. And we used an example of a chef in the kitchen, where multiple chefs can work on different parts of meal at the same time, speeding up the overall process. Then we talked about some of the challenges that come with multithreading, especially concurrency issues like race condition and deadlocks. With race condition, multiple threads compete to modify the same resource, leading to unpredictable results. And deadlock occurs when two or more threads get stuck waiting for each other to release a resource, causing a standstill in your program. So these concurrency issues are common but can be managed with the right tools. And speaking of tools, we introduced mutexes and locks, which help prevent race conditions and deadlock by controlling how and when threads access shared resources. Mutexes ensure that only one thread can access a resource at a time, and locks prevent multiple threads from stepping on each other's toes. We also covered thread pools, which are collection of pre-created thread that can be reused to handle multiple tasks. Thread pools improve efficiency by reducing the overhead of constantly creating and destroying threads, and they are especially useful for handling a high volume of short tasks. Finally, we looked at some real world example as well in this video of multi-threading, including web server, video games, and social media apps, from handling multiple user requests to processing graphics and physics in real time. So, multi-threading is used in a wide variety of technologies to improve performance. And in conclusion, multi-threading is a powerful tool that can dramatically improve the performance of your application, but it does come with the challenges. And by using mutexes, locks, and thread pools, you can actually manage the challenges and ensure that your programs run smoothly and efficiently. Thank you so much for sticking with me until the end of this video. Today we covered the basics of multi-threading and how it can make your software faster. If you found this video helpful, please give it a thumbs up, and it really helps support the channel. And if you haven't already, make sure to subscribe and turn on notification so that you don't miss any of the upcoming videos. We have got a lot of great content lined up, especially on the backend engineering, and I promise you won't want to miss it. Also, don't forget to join Prepping Telegram community for the latest internships and job opportunities. And we are all about learning and growing together. So it's a fantastic resource for anyone looking to break into tech industry. Thank you again for watching, and I will see you in some other video.